So I welcome you all in this course, Introduction to Heat Transfer, a practical oriented approach. Myself, Amraraj Sawant from Department of Mechanical Engineering. So I welcome you all once again. And in this course, we will have a brief and short introduction about heat transfer. So you all undergraduate engineering student are going to see this heat transfer in your core subject in, I think so, third year. But in this course, you will have a crisp and a basic understanding of how the heat transfer will take place and what is the relevance of that concept or ideas or the laws behind our practical knowledge and the practical scenario which we are dealing with in engineering applications. So I welcome you all once again. So this course is designed basically within the 14 lectures. So after every lecture you will have an assignment regarding to that particular lecture, and you will have to attempt that assignment online, and the link will be provided with the lecture in a description. So we will have lecture afterwards. You will have open discussion forums. So if you have any doubts, ask me freely. So I welcome you all, and let's start the discussion today. So for today's discussion, lecture number first, the introduction to heat transfer. So briefly I will go through the history of heat transfer. So James P. Joule experimented in 1843, and he disproved that the old idea that heat wasn't a fluid, heat is a kind of energy. So before James P. Joule experimented, before that the scientists were think that the heat is a kind of a substance or a kind of a fluid that can be transferred from one side to the another side. But throughout his experiment, James P. Joule had experiment in 1843. So after that he discovered that the heat is not a form of a fluid. So fluid means what? Fluid means a combination or a types of a fluid that includes liquid or gases. Okay, so James P. Joule experimented and discovered that the heat is a kind of energy, not a particle. So the heat is a kind of energy that moves between the two particles. Okay, so he showed that the heat is energy, and from the motion of the atoms or the molecules of any substance. Okay, so as the faster they move, the hotter something gets. Means what? The let's say any solid cube. Okay, any solid cube, if you go and see that solid cube in under microscope, then you will observe that it will contain of molecules and atoms as you learned in 11th or 12th standard. Okay, while that atoms or molecules are attached to each other, when they vibrate through their central distance, so that vibrational energy causes a heat transfer effect. Okay, so while at one end, while the metal is getting heated, the atoms or molecules between them will get vibrated, and that vibrational energy will transfer the heat from one end to the another end. Okay, so the James P. Joule worked helped everyone understand the heat isn't a fluid. Okay, it is just energy of tiny particles moving around randomly. So it is a form of energy that is moving around randomly because of vibrations of molecules or atoms between the solid or liquid or gases. Okay, while that molecules or atoms are vibrating with their central position. Okay, they are not just vibrating somewhat in a larger extent, but they are vibrating in somewhat their central position with respect to their central position, and while vibrating that, they transfer the heat as a energy. Okay, so likewise, just see in this figure, let's say this blue molecule and these red molecules are vibrating with each other. Okay, let's say at this end I heated this cube. Okay, at this end I heated this cube with some burner. Okay, so while I am heating this cube at this end, So the heat energy will get transformed, not a molecule get transformed. Okay, the heat energy will be transferred because of these molecules are vibrating with their central position. Okay, and the heat is transferred through this end to the another end by the virtue of or by the vibration of these molecules. Okay, so heat transfer in everyday life, as we just now see the molecular aspect of heat, how it is transferred with the molecules or with the vibration of that molecules. Okay, but how the heat transfer will affect or will play an important role in everyday life. Okay, as you just observed, generally a cold drink can, okay, if you put that cold drink can in a room temperature, you will observe that after getting it from refrigerator, if you put that cold drink can in just room temperature or a table, you observe that the thin layer or some water droplets are forming on the surface of that cold drink can. Okay, so how they are formed? So basic idea behind that, the if you are known that the second law of thermodynamics or the nature's law, that the energy is always flowing from higher energy level to the lower energy level. What it means, if you say in the example of cold drink can, the cold drink can is having a temperature but obviously lower than the surrounding temperature. Okay, let's say surrounding temperature is 35 degrees Celsius. Okay, and cold drink can with respect to the surrounding, it will have 5 degrees Celsius temperature. Okay, so what is the higher energy level is a 35 degrees Celsius, which is the surrounding temperature. So the energy is always flowing from higher energy level to the lower energy level. So while transforming that energy from higher energy to lower energy, the surrounding air of that cold drink can will have some water droplets, okay, water vapors, and that water vapors will get condensed as they are in a contact with the cold drink can, which is having a lower temperature. That is the phenomena, or that is one example of heat transfer in general or everyday life. Okay, so the heat flows from the hot to the cold until the temperature becomes equal. So heat transfer is a phenomenon always takes place when there is a temperature difference. If the cold drink can and surrounding is having same temperature, then there is no liquid drops formed on that surface of that cold drink can. Okay, so for doing heat transfer or for getting heat to be transferred, there must be a temperature difference needed. Okay, and this is a natural process, continues until the thermal equilibrium reaches. What is mean by thermal equilibrium? That the thermal equilibrium is equal to a temperature will become equal of system and surrounding. In the case of cold drink can, the system is a cold drink can and surrounding is atmosphere. Okay, we will see this example in some image diagram. Okay, so this is a diagram which explain that, let's say this cold drink can is having 5 degrees Celsius temperature. Okay, and the surrounding which is at 30 degrees Celsius. Okay, so heat will always flow from higher energy level, which is 30 degrees Celsius, okay, to the lower energy level, which is a 5 degrees Celsius. Okay, and while transferring the heat from higher energy side to the lower energy side, the atmosphere will have water vapor content, the atmospheric air. But obviously, if you don't know, the air content water vapor, nitrogen, oxygen, and some other particles as the pollutants. Okay, so the water vapor near this surface of this can will get condensed, okay, and form droplets, due to which it will get reached up to dew point. Okay, what it means, that if we add some amount of water vapor in some constant or some, let's say in a controlled volume, okay, or let's say in a beaker, if we add some water vapors and that beaker if we cool by, let's say, some ice, then that water vapor will get condensed and form a droplets. Same phenomenon is happening here. Okay, so heat flows from warmer air to the cooler can, as I said, from higher temperature to the lower temperature. Okay, and the air near this can cools and reach its point, dew point. What it mean to say that the air which is having the water vapors will get condensed because of the surrounding will be at lower temperature. That means this can is at 5 degree Celsius temperature, so that's why it will get condensed and form dew or a droplet. Okay, so water vapor condense on the can surface and forms droplets. Okay, so what is the heat transfer? Again, we are just brushing up your ideas and some concept about heat transfer. So in this course, likewise I said, you are going to see the basic and the crux behind the heat transfer, and if you thoroughly go through this course, I will definitely assure you that your basic will be clear throughout your engineering. Okay, so what is the heat transfer? The heat is energy transferred due to the temperature difference. Likewise, before I said that if there is a thermal equilibrium, or if there is a no temperature difference, then nothing will transfer. There must be a temperature difference. Okay, so heat is energy transferred due to the temperature difference. Okay, likewise in a before example, there is a temperature difference. The surrounding is at a 30 degree Celsius and this can will be at a 5 degree Celsius. There is a temperature difference of 25 degree Celsius. If both are at the same temperature, then there is a no temperature difference, and because if there is a no temperature difference, then heat cannot transfer from one place to another. Okay, or from one system to surrounding. Okay, so heat studies how fast and how much energy moves. So in further lectures we will see the difference between the heat transfer and thermodynamics, but right now the heat is the study of how fast, how much and how fast with respect to time. Okay, with respect to some certain time, how fast the energy will get transformed. Okay, so it involves conduction, convection and radiation. These are the types of the heat transfer. We will see it in a thoroughly in next lecture. So understanding temperature gradient. First of all, what is mean by the temperature gradient? So the temperature gradient, okay, is equal to the rate of change of temperature with respect to a distance. Okay, so what is mean to say here? Let's consider this example. This is a metal rod. Okay, so I heated this metal rod at a one end. Okay, with some burner or some furnace. Okay, so this hotter side, let's say, is at 100 degrees Celsius. Okay, and this cooler side, which I don't heat, only I am going to heat this rod at a one end. Okay, another end is I just kept at atmospheric temperature, whatever. Okay, so this cooler side, let's say at a 20 degrees Celsius. Okay, so let's say this rod of length 2 meter, whatever you can assume it, but I just say that this metal rod is at of 2 meter length. Okay, one side is heated at 100 degrees Celsius and another side I kept just at a atmospheric temperature, or another I will cool that side. Okay, because atmospheric temperature is never at 20 degrees Celsius without any external work. Okay, so let's say this side is at 20 degrees Celsius. So from this end, okay, from this end to this end, okay, let's say 2 meter, okay, of this length, how the temperature is going to vary across this length. Let's say I put a section number this one. Okay, okay, and this section number 2. So while heating this rod at this end, okay, with a burner or some another things or furnace, so the temperature here is 100 degrees Celsius and another side is the temperature is 20 degrees Celsius, but obviously I am just heating a one end of a rod, that's why the temperature is going to decrease across this length. Okay, let's say here is 100 degrees Celsius, here it may be 80 degrees Celsius. Okay, and at a section number 2 it may be 40 degrees Celsius. Okay, so the temperature gradient is a term where this temperature changes across the length. Okay, mathematically it is delta T divided by dx, okay, or dt divided by dx. So that means the temperature is changing across the length, and how it is changing is to be calculated, or the term used is temperature gradient. Okay, so heat flows from hot to the cold end due to this gradient. Okay, so the heat is flowing from this end to another end. Just previously in previous slide I just explained, at a molecular level the heat is transferred because of vibrations of some molecules and atoms or some free electrons. And right now I am saying that the overall this heat is going to transfer from one side to the other side due to the temperature gradient. Okay, because the temperature difference is there across this length. Okay, so how the heat flow in a metal rod? Okay, let's say steady state conduction shows a linear temperature drop. What it mean to say here? A steady state means the properties of any or heating, or the properties are not going to changes with respect to time. Okay, so it shows the linear temperature drop. In previous slide you just see here the temperature drop is a linear. Okay, so for steady state, whenever the properties or the heat, okay, is not going to change with respect to time, then it shows linear temperature drop. That is, the graph of temperature versus length it shows straight downward slope. Why it is showing a straight downward slope? Why it is not showing the slope to be upward? Because we are here, another side is we kept at a atmospheric temperature. We are not hitting this side, we are hitting this side, and this end is we kept at a atmosphere. That's why the temperature is always going to be decrease. Okay, if we heated this end, okay, if we are going to heat this end, okay, and we keep this end at a atmosphere, then this graph will show a upward direction. Okay, so in previous example the graph will show straight downward slope. Okay, what happened when the slope is getting constant? At a constant, the heat or heat transfer will be uniform. What is mean uniform? Uniform means with respect to time and distance, the heat is going to be equally transferred. Okay, with respect to time and distance, the heat is going to transfer equally. Okay, or it is not going to change with respect to time and distance. Mathematically you can say that delta Q divided by del T is equal to 0. Also delta Q divided by del S is equal to 0, where T and S are time and distance. Okay, so whatever here the case is, just you see the picture of same thing. One end is heated, okay, one end is heated, and another end, if we keep at low temperature or atmospheric temperature, the heat will going to transfer from one side to another side. In general, you just gone through this example, because if you put some rod, okay, in chula, okay, and another side of that rod is not in that chula, but you will feel heated that another side. Why it is so? Because the temperature difference is there across that length, and that temperature difference causes the heat transfer to be transferred. Okay, the heat to be transferred. Okay, so another general life example or real life example is evaporative cooling in humans. So what is mean by evaporative cooling? So everyone of you will observe or will feel where you have feel that in summer season, okay, you feel very sweat. Okay, so why that sweat happens? Okay, because of some metabolic rate will increase due to exercise. Okay, not in only in summer, in every time, if your metabolic rate will get increase due to the exercise or running. Okay, So then your sweat glands, okay, of your skin will be open, and from that sweat glands, our body, human body, is a extremely best example of engineering created by some energy. So that pores will form a sweat, and because of that sweat form, the heat will just be in before slides I just said that the heat will always flow from higher side to lower side. Okay, so while our body is having heated up, okay, so we have to control, or our body have to control that temperature. Okay, for that our body has some mechanism to control that heat. How it is so? By creating a sweat, and while creating that sweat, the sweat is going to be in contact with atmospheric air, and the atmospheric air will also will have lower temperature than our body, while our metabolic rate is higher while exercising. Okay, so at that time the atmosphere will have lower temperature and our body will have higher temperature, and always the heat is flowing from higher temperature to lower temperature. Also, one another effect, the evaporating cooling effect, because of formation of that sweat is in a liquid form. Okay, the liquid will get evaporated in the atmosphere. Okay, and the evaporation is a phenomena that takes place in any temperature or pressure. Okay, and due to that evaporation, the latent heat, okay, that latent heat is going to be extracted or going to be transferred from our body, and that's why we feel cooling effect. Okay, that is another example of heat transfer. Okay, so first our body temperature is higher than the atmospheric temperature. Okay, and the body heat will get transferred from our body to the atmosphere, plus our sweat gland creates a liquid droplets, and that liquid droplet will get evaporated, and because of the evaporation process we will have experience something like a cooling effect. Okay, so here just likewise I explained here, just written like that. So body cools by sweating when overheated. Okay, while you are exercising, or your metabolic rate when it is get higher, at higher side, then your body will create sweating. Okay, and this sweat will evaporate and absorb the heat from the skin. Okay, absorb the heat, okay, from the skin, and it works in a dry air. It works best in a dry air. What it mean to say, if the atmospheric air is more drier, and while your body is creating a sweat, then the water vapors will going to be absorbed by the atmosphere, and if that atmosphere is having a dry air, then there is a more chances to absorb your sweat by that air, and while absorbing that, the evaporation effect will be get more, and if evaporation effect will be get more, then you will feel more cooler. Okay, so evaporative cooling in human is best when the atmospheric air is a dry air. Okay, so similarly here we are seeing that a general life example, and that general life example how we implement to our engineering applications. So right now we are going to see that in next slide, the cooling towers in power plant. So as you know, in our homes or in your colleges, the electricity in India, the electricity is mostly around 70% is generated by using coal. So basically the idea is behind that power plant is like that, the coal is being generating a burning power, okay, or a heat to burn or to heat the water. Okay, and that water is going to be converted from water to steam. Okay, and that steam which is having higher pressure and temperature are going through the series of turbines. Okay, and that turbine will rotate the generator. Okay, or that turbine, that rotation of that turbine will create or will generate the electricity. Okay, afterwards the steam while going through turbine, afterwards that steam will be get condensed. Okay, and that's where the power, the cooling tower will be come into picture. So there are two aspects. First, basically, while the steam is going from turbine, if we put directly to the atmosphere, what will be the effect of that? So first, it will cause damage to environment, and second of, it will cause a back pressure on the turbine, and that will cause lower in energy efficiency of that turbine. Okay, so back pressure will create a pressure on that turbine, and that's why whatever the energy will be generated normally will be get lower, at lower value. Okay, so that's why that steam after the turbine will have to be get condensed. Okay, so for that the cooling tower is whatever in our engineering application we use cooling tower. Okay, so hot water is sprayed in towers and the air causes evaporation. Same phenomenon whatever we seen in a previous slide, that evaporation of human body or evaporation of sweat in a human body, same phenomenon is using here in engineering example. So the hot water or hot steam which is coming from the turbine is spraying on that here in this cooling tower, and the air will will be forced through the forced plan or forced induction fan, and due to the air which is having at a lower temperature and that water vapor is having higher temperature, that will be get mixed, and due to the air is having lower temperature, the water droplets are formed or will get condensed and will collect at the bottom, and again we can use this water for generation of steam. This here you can see a smog or a fog. It is not a smog or a fog, it is a water vapors highly in at high temperature. Okay, so in previous slide we just seen that how the cooling towers in power plant uses the evaporating effect, which we have seen in previous slide, like in human body sweating. So how these cooling towers are using evaporating effect to transfer the heat from the hot steam to the water or hot steam to the cold air. Okay, so this is an engineering example, and also one another example of this evaporation we are using in agriculture. So the misting system in agriculture. So many of you are farmers or your parents are farmers, you have seen that misting system. So misting system also is working on same phenomena or same principle of evaporation. And why it is so? The water is mist or sprayed in a greenhouse or farms. Okay, and this evaporation cools the air, same likewise in a human body sweating. Okay, and it helps the plant to maintain their temperature in hot summer. Okay, and reduces the heat stresses in crops or in animals. Nowadays some misting system for the animals also used for better or for more production of the milk. Okay, because the body temperature of animal, if they are at a somewhat in a equilibrium or somewhat stable with respect to atmosphere, then they will produce more milk. There is one concept and some research is going on in that field also. So mist system or misting, likewise the water is spraying in the form of the droplet over the crops or the animals, and that droplet will have the evaporation effect, likewise before we have just seen it, and that evaporation effect will cause the heat transfer from the hot body of plant or animal or human to the atmosphere. And that's why the body, the plant or animal or human body will have a cooling effect because of evaporation. Okay, so thank you very much for today's lecture. So this lecture, just briefly I revise that the heat transfer is a phenomenon only because of temperature difference. If there is a no temperature difference, that means if there is a thermal equilibrium, then the heat will not going to transfer. first basic thing is there. And another basic thing is the heat is transferred because of vibrations of atoms or molecules with their center position, and these vibration will cause the heat to be transferred from one end to the another end. Okay. Second is a temperature gradient. Because of temperature difference is present across the length, across a certain length. Due to this temperature difference across this length, the term called as a temperature gradient, and this temperature gradient is present, and that's why the heat is going to transfer from one end to the another end. Next wise, we have seen such examples like evaporating effect in human body, or cooling towers in a power plant, and the misting system in agricultural. So that examples, just we have seen an additional effect is called evaporation effect, and that is also causes because of heat transfer to be transferred from hot energy level to lower energy level. And just we have seen a general life example like evaporation effect due to sweating in human body, and cooling towers in power plant, how they cool the steam whatever is outletted from steam turbine, and it is cooled down or condensed to form again water, and that water is again we are using for generation of steam. And also the misting system in agricultural. So in agriculture, misting system is same using of same phenomenon of evaporation to cause a heat transfer from hot body to lower energy level, okay, or higher energy level to the lower energy level. In agriculture we use for plant, animals, and etc. Okay. So thank you very much for this lecture. After this you will have an assignment of 20 multiple choice question. You will have to attempt that, and I will provide an online link for that, and the results for that assignment will be just published afterwards, and you will know your result, how much you have gained. So I will provide detailed notes of this lecture after this lecture in a description box, and also for this course Introduction to Heat Transfer, a practical oriented approach, I will provide an ebook after this course, and which also we published that online, and you can find that lecture also and ebook in the description box. So thank you very much.